Okay, hi everybody, and welcome to the machine learning panel discussion at the ARM Research Summit. I'm Mattina. I head up ARM's machine learning research lab, and I'm very happy to be here today, and super happy to be joined by Pete Warden from Google and Vijay Janapa Reddi from Harvard. Just a few quick words before intros. Both Vijay and Pete have been really instrumental in enabling machine learning models onto very small, highly constrained hardware platforms. So think, Cortex-M devices with very limited flash and SRAM. And we're going to spend some time today discussing the state of the art in what's called tiny ML, which is this phenomena of ML on highly constrained devices. And we'll chat about some other stuff as well. We're not wedded to just tiny ML, so we'll see where things go. One or two logistical things. We have about, I believe, 45 minutes, give or take, allocated for our chat today. And I'm also told that audience members can ask questions via Slido. So provided I can figure out how to get to that, we can get your questions in as well. Okay, so with that, I guess I'd just like to ask Pete and Vijay to introduce themselves. Maybe we'll start with you, Pete.
Sure. Thanks so much, Matt. And hi, everybody. So I'm the technical lead of the TensorFlow Lite for Microcontrollers project at Google, which is an open source machine learning framework that has actually had a lot of contributions from ARM as well. So it's actually been nice to be working on a real collaboration between the companies. And yeah, I'm really excited to be here. I know Vijay and Matt well. They're both doing some pretty amazing work. And I'm excited to see what we talk about.
Thanks, Pete. Vijay, can you introduce yourself, please?
Yeah, thanks, Matt, for having me here. Hi, folks. I'm Vijay. I'm a faculty member at Harvard, which is my full-time gig, but I like getting myself into a lot of trouble with industry folks, so that's how I know Matt and Pete. One of the things that interests me in the machine learning space is sort of really looking at it from a system standpoint and kind of understanding how you compare any two machine learning systems and sort of what does it really mean to enable machine learning in order to solve application use cases. So that's the kind of question that kind of keeps me up at night. How do you really deliver AI in products?
Nice. Okay, thanks, guys. So, as I was thinking about the panel and the background of folks that are likely to be attending, of course, some people will have a good background in ML and they'll know what tiny ML is, but others probably not so much. So I thought one way to start our discussion might be to just sort of try to crisply define what tiny ML is. So in a nutshell, when we're talking about tiny ML, what are we actually talking about? And I guess I'll put that to both of you.
Yeah, maybe I can take a stab at this because this is something that we've, it's been a lot of discussion about because there's agreement that there's this new area, but how to define it has been, a real open question. My favorite definition is running machine learning on a device with below 1 milliwatt total system power. Which really gets you into, hey, you're able to run some kind of machine learning on sensor data for like a year or two on a reasonable set of batteries or using some reasonable amount of energy harvesting. So really like untethering machine learning from mains power is one way that I think about it.
Yeah, I think about it sort of as the simplest way is to kind of think about it from the perspective of, can I run machine learning in a coin cell battery? And what are the interesting application use cases that I can unlock with that? And I think it's a very simple way to kind of frame it. given where the rest of the ecosystem is. You take that CR32 kind of small little battery and you're like, okay, what kind of things can I do with this if I put machine learning capabilities on it?
Yeah, I like how both of you define it basically in terms of sort of battery life. So it's that's sort of the core constraint. So it's not gigaflops necessarily, although of course gigaflops are going to flow from the battery life, but the battery life is sort of a nice way to frame the discussion here and disconnect it from the mains. So you guys mentioned, both of you, I think, mentioned sort of the applications in your description of TinyML. So can you give folks a flavor of maybe some prototypical TinyML applications? Like what sorts of actual end user or end programs are we talking about here when we're talking about TinyML?
Do you want to go first, Vijay?
Take this one, Pete. You can give the product-oriented sort of spin. I'll give my crazy academic-oriented spin.
Yeah, so the number one application, and the one that's been around for a long time now, is voice recognition. So if you've got a smartphone that's made in the last few years, it's probably going to be listening out for a wake word to start the voice assistant. And because the main ARM Cortex-A processor will burn hundreds of milliwatts, even if it's just kind of like running in the background, the CPU is turned off, but there's an embedded processor that's sitting there listening to the audio microphone stream coming in and trying to recognize, using a deep learning model, both Apple and Google solutions. Apple actually published some interesting blog posts about this a couple of years ago, using deep learning because it's the most effective way to kind of try and spot keyword, wake word phrases. And then if one of those is spotted on the embedded chip, it then wakes up the application processor to kind of then like deal with what's happening. So that's been this kind of, the very first application that I ran across of TinyML, and it's been there sort of, quietly in the background for a long time. What's really changing is that there are starting to be all sorts of other things that you can do on phones and in standalone devices. One that I can point to that's also in the audio domain is if you actually have a Pixel phone, on the lock screen, when the CPU is off, it's actually sitting there listening out for music. And if it hears music playing, it will attempt to identify it. And that music detection algorithm is also running on a little embedded microcontroller or DSP, depending on your device, running a deep learning model. So there's a lot of other applications as well around, trying to detect accelerometer movements and actually do interesting things when, again, I'm talking about the phone because that's a very short-term, way of demonstrating this stuff. But, when the phone's being actually moved around, you can actually use the accelerometer to detect what's happening, do activity recognition, for example. And where I think things start to get really interesting, though, are once you move into energy harvesting and battery applications, whether it's things around, wildlife monitoring things in buildings. One of my favorite problems that comes is very well, it used to be very close to home when I was going into the office, was I'd be sitting in a conference room and the light would go off because I'd be like, I'd be slumped in a meeting and not moving enough. And so instead of having like a motion detector, can you have a little image sensor that actually detects when a person is present?
Interesting.
And yeah,
Yeah, those are great. And you know, I guess one follow-up to that, I have the sense that really most of TinyML, let's say 90% of it, we're really talking about neural net models. But I wanted to test that out with both of you. Do you see it that way? That really it should be called, you know, tiny neural net, because that really is the predominant type of architecture we're using for these applications you're talking about, or is there scope and interest in other non-neural approaches?
I think the general thing is that people, I would say, are not fully sold on just going with neural nets yet in the tiny space, because machine learning on these tiny devices, specifically because it's very domain specific, right? You would say machine learning is domain specific. You know, it's a genre that kind of like, you know, stands on its own. But TinyML, I would say, is even more domain specific, because typically when you're doing machine learning for this stuff, it's you're dealing with one particular use case. And often when you're doing these use cases, you're looking for extreme efficiency, right? Again, if we're trying to operate things on a coin cell battery, that requires extreme efficiency. Neural networks are inherently computationally intensive, right? We kind of know that. And so there are other methods like decision trees and random forests and those kinds of methods that people feel like, well, they're computationally much more simpler and they get you to relatively about the same amount of accuracy. So I think the verdict on whether it's all going to be neural network based or whether it's going to be some mixture of traditional methods, traditional machine learning methods combined with neural network based approaches, I think that verdict is still out to be seen. Though, given how we've all been doing things, I think we'll plow ahead with neural networks on everything.
Yeah,
yeah, and I
yeah,
guess
yeah. Go ahead, Pete.
yeah, and I was going to say I'm actually, you know, I'm maybe selling my own framework here, but I'm actually more bullish on the neural network side, mostly because I've looked at a bunch of product teams, especially within Google, like the speech team, who are coming to it like pretty, you know, without much of an axe to grind. They're just looking for the best way to do things. And they've evaluated a lot of approaches and they've ended up, you know, using the neural network approaches as kind of a, you know, the standard tool in their toolkit.
Yeah, yeah. I think that's right. I think I share that intuition, and I would say also there's just a ton of research and engineering around compressing these neural models, you know, either to make the parameter space 10, 100x smaller or reduce the number of flops per inference. It seems like every week there's a new approach on Archive, or a new technique on Archive, where we're able to take a model that was previously, you know, too big, too computationally intense, a neural model, I should say, and fit it into the form factor of one of these tiny platforms. So I think that's a super interesting sort of subcategory of neural net research. It's, you know, more about the computational and the footprint angle. Um,
Actually, on
yeah.
that point,
So
if I can add that,
yeah. Go
talking
ahead.
about making networks smaller, right? I think one of the things is that, and that's quite unique in this 10ML space, is the fact that it's more sensor oriented or sensor driven. And so typically we tend to think of everything being vision oriented. Like I say, like, you know, so much of the effort is kind of pumped into the vision side when you typically think of networks. I think in the TinyML space, because it's really about sensors, I think the networks can get smaller, but you got to get creative about what does perception really mean in the TinyML context. Like perception shouldn't just be about vision pixel processing, right? It's about looking at that sensor fusion, because I think you can get a good amount of data, and output just based on raw lightweight sensors. And I think that sort of co-design between the sensor and sort of looking at the networks to solve the right problem would be an interesting way to kind of look at you know, why we might be able to get the networks down enough that yes, that would be the de facto method.
Yeah. Yeah, I think that's a really good point. In fact, it kind of segues into something else I wanted to ask both of you about. given that we've got, Pete's metric, for TinyML needing to fit within a milliwatt power budget, what do you have about the sense of these models? Let's stick with neural for now, running on CPUs, so like, as we mentioned earlier, Cortex-M class, versus some, more custom NPU accelerator. And I guess to frame that up, right, presumably you can get lower power if you have a more tailored piece of hardware, aka an accelerator, right? You should be able to execute said model more efficiently. But of course, that comes with design complexity and area cost. So any intuitions around whether TinyML is going to move towards executing these neural models on NPUs, or whether you think it's the flexibility and generality you get from a CPU is going to be the dominant way to execute these models? Maybe Pete, you can start with that one.
Yeah, and I think this is actually coming back to something you were saying about, hey, neural networks are computationally intensive compared to traditional ML techniques. And from one of the interesting things has been that that's actually kind of been an advantage in a weird way, because you can actually, unlike a lot of traditional ML techniques, you can gain a lot of accuracy and a lot of sort of, effectiveness just by throwing more compute, like making the model more compute intensive without really changing what it's doing. So what we've seen is that there are a lot of product teams who say, hey, the limiting factor for me is how much compute I have available within my budget. If you could give me, if I could have more compute to run a more complex model, not necessarily a larger model, but a model that's doing more computation internally, then I could deliver better results to users. And that's where a lot of the specialized work around sort of things like NPUs gets really interesting, because, I'm not a hardware person, but what I constantly hear from the hardware people I talk to is that arithmetic is really cheap in terms of power usage. Memory access is really expensive in terms of power usage. So any time you can come up with a problem that's really compute intensive and compute bound and not memory bound, hey, we can come up with hardware to help with that. And that's really where the NPUs kind of come in. Now, the big challenge for especially the first generation of accelerators was that they were based on what neural networks were doing at the time that they were designed. And damn, researchers keep inventing new techniques to improve the accuracy and to reduce the sort of, the size of neural networks. So what is promising about this next, the newer generation of accelerators, things like Ethos, for example, is that there is a lot more programmability and there is a lot more interaction with the actual sort of, general purpose CPU to allow people to run much more flexible kind of models that hadn't been thought of when the NPU was initially created.
Yeah,
I think accelerators are great though, but I think one thing that's key though, Pete, is that people often focus on just the IP alone, right? And say, okay, well, I've got this blazing accelerator for neural networks. I think the big thing, as we all know, is like once you integrate this into the application pipeline, it's the coupling that happens between the CPU and that IP that really gets you or does not get you the efficiency gains that you want. So I think by sort of focusing on that, we've written papers on this, like this notion of what's this AI tax that you have, right? Which is like from the point you get the data from the sensors, how efficiently are you moving it through the pipe? I think like in the TinyML context, I think that that really, I think, gets amplified because you're operating with such low budget, right, in terms of the power. And you said, if the data movement is inefficient, no matter how efficient your compute is, you're going to be burning up that power in moving those bits around. So I think sort of looking at that really tight system integration from the sensor to the general purpose compute to the accelerator, I think that pipe, how lean and mean can you make that pipe, I think is really what the key thing should be for architects.
Yeah, that's a good point, Vijay. Yeah, and sort of keeping the software overheads manageable, right? So if I've got some bits that or some phases of the computation that work well on an NPU, but then I want to switch over to the CPU to execute some weird new activation function, I want to make sure I can do that without going through tens of thousands of driver stack lines of code to make that switch. So yeah, that's your systems level view comes through here, and I think it's right. Yeah, Vijay, let me ask you this. So Pete sort of articulated nicely some of the current applications that are running and that he would categorize as TinyML. So the wake word identifying songs that are music in the background. Let me ask you to speculate a little bit. Let's say we do this panel again in 5 years. What, if you had to guess, what do you think the key TinyML applications are going to be doing in 5 years?
I can't say there'll be like any one killer thing in this sort of space. I think TinyML, the beauty about it is that it's got to be pervasive. I think if it's successful, it's going to be pervasive. So like some applications that obviously people are talking a lot about, right, is like agriculture. For instance, like when you're sowing your seeds, the one thing I would imagine is that when the machine is putting the seed down, you put a smart seed down, right, which is sort of collecting the soil conditions and so forth. Like, so it's got to be sort of things that happen at scale. So agricultural farming, that's a complete value add. So that's one domain, I think, where I think there's potential for real impact, right, at the societal level. I think another one that's really interesting is sort of like as we move forward in terms of manufacturing, and we're talking about like the next generation of manufacturing plants that we want to build. How does AI get enabled in that? And like, and if you're looking at it from that standpoint, it is TinyML because it's all about like that manufacturing is not like, it's having the subtleness and the real-time responsiveness that you will need at the sensor level when you're manufacturing, like, if you're rolling out sheets of metal, how thin that is. I mean, if you really look into those kinds of spaces, you find that you cannot beam stuff up to the cloud. You cannot do some big processing. It's all that stuff is happening right at that endpoint. So I think like those are some bigger kind of application use cases to seriously think about, because I think that's what's going to move the industry forward, like in terms of really wanting to invest in TinyML. Then I think a third one outside of agriculture or manufacturing, I think it's like things around tiny robot learning. So this might sound a little crazy, but like today, we talk about robotics, we talk about autonomous machines, and we know they're coming down the pipe in one form or another. But if you really look at it, it's like when you really, really need it, right? It's very hard to have functional machines. So let's take a specific example, right? So let's say you have a collapsed building, a search and rescue kind of a scenario, and you want to send in drones. And in those kinds of scenarios, very often you want very small and agile drones, not big DJI drones that like they just won't fit through. They're not agile enough to kind of move through search and rescue scenarios. So they have to be extremely small. And if they're extremely small, you got to worry about the payload. You cannot have a fat camera on top of it. So you got to really improvise on other types of sensors you're going to have, right? So that kind of goes back. And those systems, like for when you have like nano drones, things that can do search and rescue at scale, when you farm out a whole swarm of them, that's got to be really small. So that's going to be based on some sort of microcontroller or some sort of micro NPU. I think that's a place where we're already seeing a lot of innovation happening right now. There's a lot of excitement in that robotics, and tiny robot learning is what I'm calling it. I think there's a lot of interest in that space because the application is a bit different. There are real-time requirements where if you have a small little network that's running, it has to run very efficiently, and it has to be supported carefully because it interacts with the flight control stack. I think those are problems that are totally engineering oriented that we can solve. But I think like those are some of the frontier aspects of tiny machine learning, like things that we don't talk about on a daily basis, but things that I would see in 5 years or 10 years where the government really wants innovation.
Nice. Yeah. Pete, anything to add to that?
No, I mean, I feel like we're at this point where we have this tremendous new power to be able to solve a whole bunch of problems. Like we've got an awesome hammer, and we're convinced that there's going to be some, killer applications. But it is such a new capability that it's tough to point to, hey, this is a tried and tested use of this. But this is part of the reason why I'm sort of preaching the gospel of TinyML is like, let's reach some people who have domain, who are in domains who are like, oh wow, yeah, that would be super useful.
That's a great point, Pete.
I agree. Yeah, go ahead, Vijay.
Sorry, man. That's a great point. The thing that when you just said that, how do you reach people? I think this is a really interesting time, because think of it. I feel like this is sort of the era of when smartphones came about. That's kind of what dawned on me, because it's like you got this base platform that is remarkably powerful, right? And you as an individual developer, you don't need some ninja chops to be working in some big company. You don't have to have the job. As long as you can get a cheap little Android phone and you got the Android ecosystem that you can do builds on, so you can write up an app, and if you're creative, you come up with something that's just like, well, great, now I can sell this for a few $1 million. I think that sort of thing has not quite happened for the machine learning space yet, but I think with TinyML, you really you get into this ecosystem where, because it's so cheap, the embedded hardware is so cheap, right? And then you've got this remarkable architecture, this base platform, right? This neural network thing that we've kind of figured out enough that now most people can work with it, right? Then if you put that together, and the third thing, if you can teach them how to do it, and you provide them free software like TensorFlow, the stuff that Pete's team is putting together, my gosh, I think we don't need to, this is one case where I think we don't need to worry about what the key use case is going to be, because some kid someplace is going to build it for us and he's going to change the world. Like, that's honestly what I think, because for once you can really reach people, right? People can take this and they can actually do stuff. They're not just, oh, look, I can predict the stock market price and I have now learned machine learning. Okay, great. Now I hope you get a job. Versus here, you can actually build something that's actually useful. I think that's quite remarkable and powerful about this technology.
That's great, Vijay. It's a great segue into another sort of space I wanted to get your and Pete's views on, since I think both of you are well tied in with the educational community. Vijay, obviously, you're a professor at Harvard, and Pete's generating content and courses for TinyML. So, one thing I wanted to ask you guys, just to switch things up a little, if you could recommend like a single online course or a single book on machine learning to recommend to someone who wanted to get into the field of TinyML, what would that be? What comes to mind? Maybe we start with you, Pete, on this. And you can't name your own book.
Damn.
I was going to jump in and be like, well, I heard about this book. Okay, so, well, this is a true story.
Yeah.
So talking about TinyML, right? This is a great question, because I was thinking about this, right? For the exact reason that I mentioned earlier. Wow, like you can really empower people. And so I remember like waking up one morning, and I think it might actually be a Saturday or a Sunday, and I was like super psyched about this. I was like, oh my gosh, I actually think we can write a book on this, and people would want to read this book. And I was so excited. I opened up my email. I started typing a message to Pete Warden, and the subject was TinyML book. And then I started typing out. I was like, hey, Pete, and then I thought, well, let me just kind of make sure. Let me just Google this, just in case there is a book out there. And obviously, I type in TinyML book, and this book pops up in O'Reilly. And I was like, damn it, we got scoop. And then I look at who are the authors. Oh, it's Pete Warden and Daniel Starkey. I was like, Pete has already thought about this. And if he's already got the book published and it's on Amazon, he must have already thought about this about a year or 2 years ago. So that's a personal recommendation coming from a real story where I was looking for it. The first thing I did was go and order it. It took me about 5 seconds and I was like, buy it. I got to read this thing. I got to see what's in here. And then I had to go back to my email and be like, Pete, so I had this great idea, but then I found your book. So let me know if there's some of the book we can write together. And that's a true story. I'm not kidding.
That's great.
Funny. Yeah. Yeah, I mean, am I allowed to recommend my own software?
Yeah, all right, we'll let you do that.
Yeah. No, because honestly, the thing that I love about this is like Vijay saying, you can just kind of grab, like, I actually recommend grabbing the Arduino library and just grabbing like an Arduino BLE 33 cents board, and you can literally just use the Arduino examples to start doing some sort of speech recognition, some, accelerometer gesture recognition, even, and you'll laugh when you see this wiring setup that I have. That's 16 jumper cables going from a camera to an Arduino, but you can actually do that kind of person detection that I was talking about earlier. And the nice thing about that is you just use the Arduino examples. You don't even have to do any coding yourself to get started. And then start, I'm very much somebody who learns by just grabbing stuff and like playing around with it. And there's now some really great sort of ways of doing that. And there's also, Edge Impulse is a company that sort of really tries to package together a strong end-to-end sort of experience using a lot of the same technology. So honestly, I really recommend people just, if they're like me, they just grab some of the code that's out there, start playing with it, start seeing, how well it works, what it works for, get ideas of problems they'd like to solve, and just, have fun.
Yeah, that's great. Yeah, that's great advice, Pete. Vijay, anything to tack on to Pete's comments here?
Yeah. Are we allowed to recommend our own classes?
We let Pete recommend his own software, so sure. Go.
Yeah.
I think you just did.
Yeah.
So what Pete and I have been thinking about is this, how do we empower students and how do we get them all excited about this future? And so one of the things that we did at Harvard was actually put a course together on TinyML. Of course, that's accessible just to Harvard students, but there was so much interest. There was, and I had this website up and just said this course was coming. At Harvard alone, there was an insane amount of enrollment requests for this course. I think when we did the surveys, 170 students, and Harvard, you got to remember, is not a very big school. 170 is a very big number for us. And we could only take about 35 to 40 students just to make sure we can actually support them well. But that once we saw that amount of demand, what we thought was that we should actually enable others to have access to this material where we're talking about, what is TinyML, what are the applications, what is the software stack that's involved, what are the hardware elements you need to know, because it's an embedded system, so you got to know the whole vertical slice. This led us into actually putting a course together. And then, so this is a course that's actually going to come out mid-October on edX, which is accessible to everyone for free, which I'm sure they would not like me telling you that. But you can also take a professional certificate version of it. But the key thing is that you can go to this site online, you can search for edX Tiny Machine Learning, and then you can take the course for free. And all of this material is something that myself, Pete, and Lawrence Moroney, who's a big champion of TensorFlow courseware, we put together, and we're still working on it. And in that process, one of the things that, thanks to Pete working with Arduino, one of the things that we did was kind of put this little kit together. And so what this box basically is something that you can just get online when the course goes online, and that way you you can take the course and all the assignments are everything going to be open and accessible to students or anyone, and they can effectively learn that. And from the parts and so forth, everything is kind of like thought out very carefully. So I think that's one of the things that we did in order to help bootstrap the ecosystem, right? So I think that's one thing people could do. And I think taking a step back, the way we should look at this whole thing is that there are many pieces that have to come together to really be able to land tiny machine learning. We talked about education, then we talked about the technology that we actually need. We talked about why we would actually want to do this. I think the last thing I would think that we would need to do is actually enable sort of create an ecosystem where everybody can play. And there's a lot of open knowledge and open share that's kind of going on. And Pete and Evgeny actually put together this TinyML Summit and this TinyML Foundation, which is kind of like creating these meetup groups all around the place where you kind of build a community. And I think that's important because this technology is really about accessibility for everybody. And I think if we invest not just in the technical aspects, but we actually create an ecosystem where like-minded people can come together, I think that's when the technology is going to just take off. I don't think this particular piece of technology needs a lot of hand-holding to kind of get it all over the hump. I think it's more about creating the platforms where people can actually learn about it. And that means creating a community, whether it's through classrooms or whether it's through meetup groups.
Nice, Vijay. Yeah, that really resonates with me, the community aspect of it. And yeah, I think I noticed that you set up something in Boston as well. I think there's a new TinyML meetup group in Boston, which was great to see. Yeah. So let's see. We got a bunch of questions coming in on Slido, which I did figure out how to use while we were chatting.
While you're figuring that out, I've got a question for Pete. If you don't mind me asking Pete a question directly.
Well, I still have one. I still have one for you guys. So hold your question for a second. So what I wanted to do is actually pivot away from tiny to the really big, just for fun. So, I'm sure you guys saw, GPT-3 from OpenAI, which is it's a natural language processing model, 175 billion parameters. Trained on basically a crawl of the web, and I've been sort of following it pretty closely, and I actually find it pretty astonishing. In particular, the way the model is not really trained on for any particular task. It's not fine tuned. It's just basically next word prediction, and with just that and prompts from a user, it can display pretty remarkable characteristics, I would say. There's a fair amount of debate on this. Some people are much less bullish on it compared to me. But what I wanted to get you guys to speculate on is when do you think we're going to see a artificial general intelligence? And I guess, do you think it's going to be never? Do you think it's going to be 500 years? Do you think it's going to be 50 years or 5 years? I'm curious to hear what your view of that is, given how close you are to ML research and sort of the bleeding edge here. So, any thoughts on when the robots are going to take over?
I think the true answer is we won't see it, because by the time we get to it, we would have probably done something ridiculous with AI technology that we would have gotten ourselves into trouble. That's the true answer.
So I'll put you down for never.
And I guess, and I struggle with the question a bit, just because I don't think anybody's really defined what a general intelligence actually is. I mean, you can kind of see something like GPT-3 answering the Turing test, maybe, but does that mean that it's actually intelligent in terms that we would recognize, or, a lot of people have been talking about, I think it's a guy who doesn't speak French who entered the French Scrabble championship and won because he just memorized all of the words in the French dictionary. At what point is, I see, like, maybe we're just a bunch of deep learning style neural network pattern recognition models ourselves, just all kind of glued together. And then we have this like consciousness thing that's kind of slapped on top. So yeah, I have to admit, I'm sort of, I guess I'm not that interested even in the general intelligence thing, just because I feel like I'm, we're going to be able to do so much by just kind of carrying on down this like really advanced pattern recognition approach. I'm happy to let others like dive into the sort of, the deeper philosophical questions. I just like putting together models that work.
Nice. I like the way you both dodged the question. That's
yes.
We kind of told you what we think about that space.
Yeah. Okay, good. Well, we'll see. We'll see if we're back here in 5 years, and if the robots have replaced us. So with that, let's. I'm going to switch over to the Slido stuff, since we're running up to the I guess it's 6 o'clock in the UK, 1 o'clock here in Boston, and I guess I'll just read off the top voted questions, and we can have at them. Okay, so question from Anonymous. It says, I can see how this workload, TinyML, is going to become a bigger and bigger share of the ML world. My question is, what kind of world are we talking about?
So, I mean, I guess I can take a quick stab at that, and I'm not sure if this is what the questioner is asking, but what I see is a world where you have a lot of compute happening on devices, on edge devices that aren't necessarily even connected to the internet. Like the thing that does your conference lights because it spots that there's a person sitting there, doesn't necessarily have to be, network connected at all. And really what I'm hoping is that we end up with a whole bunch of compute happening kind of all around us in this kind of like ambient sense to like help us as we go through our lives.
Nice.
I think the world that we'll get into is a world that I think we already kind of live in, which is a lot of things are just automated. And I think you're going to get into a world where touch was the big thing. It's like 2008 or so, like touch was this opened up this whole different way that we do things once we got the iPhone and we started tapping on the screens. I think like maybe in 5 years, I'm sure like, the notion of touch is just going to go away. I mean, even when I type emails, I just speak most of the time. I rarely type now. And I think more and more speech, I think, is just going to be at the forefront of things, where everything is very connected. So I think like the whole personalization experience, we say we stare at screens. I think we might take a step back from staring at screens and actually look at it as more as like it's a conversational AI. I think is going to be very, very big for us as a society. Just the way we interact, we're going to have personal assistants that are really personal, not just virtual assistants. I think that's going to be interesting, where you get these big, today when you go to Netflix, you get this recommendation of some sort, right? I think that sort of stuff will just get embedded into some sort of earpiece or something, and it's really recommendation systems running in tiny devices. I think that's sort of the most exciting thing. I think the technology aspects and the big momentum of autonomous vehicles and smart sensing and all that, that'll happen. But I think it's the question of how our personal lives are going to change. I think that's the most important question, because I think that's what we really value at the end of the day as human beings.
And maybe if I can jump in as well, like one of the things that I'm convinced is going to happen is if we have 50-cent chips that can run for a year on a coin battery that can do voice interface, can do general voice recognition, which is totally within the realm of the possible. It's not like a crazy idea. We already have like the Pixel phone running Cortex-A doing server quality voice recognition on device with like an 85 megabyte model. If you imagine that scaled down to something even cheaper and even sort of lower energy usage over the next couple of years, there's no reason that everything that we make shouldn't have some kind of voice interface. And we'll probably need something like a gaze recognition as well, so that we can tell what device you're actually looking at, so you know which one will respond. But then once you enter, that's why I think about this world of being surrounded by things that you can actually talk to and interact with without having to touch, and in a very natural kind of conversational way.
Yeah, I agree.
I think
I do feel like
very important.
Yeah, go ahead, Vijay.
I just want to close that one out, Matt. So one thing, we talk about language and stuff, but when you take a look at the whole planet, right? Like you look at the languages, there's so many languages out there. But if you look at like where machine learning is kind of deployed, especially in speech, it's a very small subset of those languages, because you need this large amount of data in order to build this intelligent system. So one of the things that Pete and I and a couple other folks are working on is like this vision that we want to have 1,000 words that we can recognize in 1,000 languages, right? It's a very small problem about that speech, but that allows you to tackle that long tail of languages that are out there, because you're looking at very small subset of that vocab. So think like looking at problems like that, I think, are important, because then we can unlock the kind of stuff that Pete's talking about is, talk to a machine. You don't need a full-on vocab. You don't need a full-on ASR or TTS engine. You just kind of need a simple, small little model that understands a handful of words. That's it.
Nice. Okay, let me pick just one or two more here, since we're running a bit short on time. From further down the list, I'll try to mix it up a little. This question here caught my eye. So Anonymous asks, is training on energy/power constrained devices an important problem to solve in the near future? So essentially, not just inference on tiny devices, but actual training and learning. And the person asks, is there any economic benefit to have such a feature? So let me put it to you guys. Do you guys see training, in situ training on these tiny devices as being something useful in the future?
So I guess I can, yeah. So my short answer is no, with an asterisk. I see a lot more opportunities for inference than I do for training. And on the training side, because we're not labeling the data, most of the neural network work, almost all of the neural network work, is around sort of, actual some kind of labeled data. It's hard to think about doing traditional training on those, on the kind of devices we're talking about, just because of the situation they're in. And what we can do, though, is things like personalization, like you speak to your phone and give it some samples of your voice, and that's not doing a full backprop over the network. That's just helping like kind of calibrate the results you get out. So that's the sort of asterisk, is there's some training like things that you end up doing, but I haven't focused on training just because I don't see a big demand for it.
Yeah, just to follow on to that, there's sort of, I think you hit the two main problems there, and they're distinct, I think. One is the obvious, or the lack of obvious labels in the data that's coming in at the edge. Like, where are the labels? And we've been quite interested in some of this, some of the self-supervised paradigms where you're able to learn and train using some pretty normal techniques, but using sort of self-supervised or semi-supervised approaches to get around this lack of labels. Glenn Hinton or Jeff Hinton and his group did some interesting work on this and contrastive learning. So I see some ways where the lack of labels may not be a big hindrance. And then the second thing you mentioned is a sort of pragmatic concern around, do we have the cycles and the power budget to run, gradient descent and backprop in a highly constrained device. And there, I think there's interesting research around potentially, sparsifying the learning process such that maybe you can reduce the computational load by 100x by only backpropagating to a very small subset of weights in the model. The thing I struggle with is actually the use cases. Like, what really are the killer use cases for learning at the edge? I can't say I see one yet. Vijay, did you want to add anything to that?
I think that's specifically where non-deep learning based methods become interesting, because they're very easy to update. There's just tree traversals usually. So I think that's where I'm skeptical if it's all just going to be about deep learning, because the deep learning, the training part is the costly part. So that's one point. I think for the second part about the training, I don't necessarily see that as sort of like on device. I don't think we should, when we talk about tiny models, we should be thinking about just the endpoint. I think you're looking at a cluster of devices, right? Like all these small little devices that you throw out, and maybe there'll be some sort of sensor hub that they're implicitly tied to, and that's where the training happens. So I don't think we necessarily need to look at it in the very traditional mindset that we have come from, which is we got these big training machines and then you do this inference and then that's it. I think we're going to start looking at hybrid solutions, and that solution is what you really care about at the end of the day. Do you really care about the training and the inference, or do you really just care about how well is this performing the task I care about? So I think we're going to more evolve into that sort of co-design sort of, sensor coupled with some compute someplace. And the endpoint is still intelligent. It's evolving.
Yeah, there might be some hybrid between backhauling everything to a centralized data center, doing it all at the edge. There might be, edge gateways sort of halfway there that are aggregating from some smallish number of devices to do some training. So that's great. I think with that, we should probably close this down, since it's after 6 in the UK and people probably want to get on with the rest of their lives. So I want to just thank Pete and Vijay. I think that was a lot of fun, and I always enjoy talking with the both of you. And I think that was a great panel, and thanks for making the time to do this.